All right, so now that we've looked at the behavior of power functions, we're going to look at now the behavior of polynomial functions. Because a polynomial function is essentially just the sum of a bunch of power functions. Now the powers have to be positive integers, right? These n minus 1, n minus 2, so on. The powers of x have to be positive integers. And there's some constant multiples in there too. These a sub n minus 1, those are called the coefficients. So I didn't review polynomials. I assume that you know what a polynomial is. So, but yes, it's just the sum of a bunch of constant multiples of power functions. So the end behavior, though, that's what we're looking at in this section, is the end behavior of different types of functions. And when you look at the behavior of a polynomial, the polynomial is dominated by the highest power of x, okay? So it's going to be, so in the long run, the polynomial function has the same behavior as the leading term, right? The leading term is that a sub n times x to the n minus 1. All right, so that a sub n is just a constant, and that n has to be the highest power of x in that polynomial. All right, so that's the key idea in this next example. We're going to look at the behavior of polynomials. So here it's just a matching. It's just a matching question, right? So if we can find the highest power of x in the polynomial, and we know the end behavior of that, then we can find the end behavior of the polynomial. All right, and then we can match it to what we see in these graphs. All right, so let's take a look at this first one. It looks like the highest power of x, the leading term, we call this the leading term. The leading term is 3x squared, right? It's the term with the highest power of x. And okay, and the behavior of the polynomial is going to have the same behavior in the long run as 3x squared. All right, now we know that even powers of x go to infinity as x goes to infinity, and going to go to infinity, positive infinity, when x goes to negative infinity, right? So it goes to positive infinity in both directions. So it looks like this has to be the this middle graph has to be the 3x squared plus 5x minus 2, because it has the right end behavior. Okay. All right, so the next one, we have g of x. Now we have polynomial. It's not written in standard form. Usually, polynomials, when they're written in standard form, have the highest power of x first, and then the powers of x descend. So if we wanted to write this in standard form, it would be minus 2x to the fifth plus 3x plus 1, okay? But either way, we had to identify the leading term of this polynomial, and it's this minus 2 times x to the fifth, okay? That's our leading term. And then we know that the behavior of the polynomial is the same as the behavior of that leading term. So remember, we have now, this is an odd power of x, right? So normally that goes to positive infinity as x goes to positive infinity. But it's multiplied by a negative 2. So that's going to flip it. That's going to flip it, and it's actually going to go to negative infinity as x goes to positive infinity, right? Because we're taking those positive numbers and multiplying by a negative 2. So they're going to be negative. So it appears that this is the one I want. This is B, right? Because as x goes to positive infinity, right, as I go farther and farther in the x direction, and it looks pretty vertical there, but as I go in the positive x direction, f of x is going to negative infinity, right? And when x goes to negative infinity, it goes to positive infinity because, we're taking negative numbers to the fifth power, which are going to be negative, but then we're multiplying by negative 2. So it's going to go in the positive direction, right? It's going to go off to positive infinity. All right, now by process of elimination, we can probably bet that this is C. But let's reason it out. First thing to do is find the highest power of x, right? This is not written in standard form, so the highest power of x appears to be this x cubed. So in the long run, the behavior of the polynomial, right, is going to be the same as the behavior of this power function. All right, so it's going to go to positive infinity as x goes to positive infinity, and it's going to go to negative infinity as x goes to negative infinity. Okay, there's no negative, there's no coefficient. This coefficient is effectively just 1. So yes, that seems to match the behavior of this, right? It goes off to positive infinity as x goes to positive infinity, and it goes to negative infinity as x goes to negative infinity. All right. All right, so I'll meet you in the next example.